What the dot product is it's a scalar quantity, and it's one way of multiplying vectors. We will also learn in the next section about the cross product, which returns something different. There's the dot product, and then there's also multiplication by a scalar quantity, which we already did. But the result, which is not a scalar, right? If you take a vector and multiply by a scalar, you get another vector. But if you take two vectors and you find your dot product, you end up with a scalar, which is, a scalar is just a number, right? Like 10 or 20 or 15. And in some cases, the dot product will give you a force. Sometimes it gives you the amount of work done. Depending on the situation, it has a lot of applications in physics. The cross product actually has...
Hold on, Mr. Weaver.
Sorry.
Come on now.
And so the cross product has several applications as well. But anyway, so the way you find the dot product, okay, is if u equals the vector which I'll call u1 comma u2, and v equals the vector which I'll call with components v1 and v2, okay? Then the dot product, u dot v, which is a little bit bigger dot than a times symbol, okay? So don't write a little teeny dot, write a bigger dot, because that means the dot product, which means something different than multiplication. But it's almost like multiplication. What this is equal to is u1 times v1 plus u2 times v2. Okay? Okay? Hold on. Oh, it's Friday, but we gotta know. All right. And dot product is easy, but you haven't seen it before, so we're gonna do it. So, for example, if I want to find a dot product, so if u equals the vector 4 comma negative 3, and v equals the vector negative 1 comma 2, then u dot v is just 4 times negative 1, 4 times negative 1, like that. That's 4 times, 4 times negative 1 plus negative 3 times 2. And you get an answer, which is negative 4 plus negative 6, which is negative 10. So when you do a dot product, you just get a plain old math answer number. And that's called a scalar. And that's a dot product. What does it tell you? It can tell you various things depending on what the application is. Okay? So some properties. Properties of dot products. One is that it is commutative. Does anyone need to go to the concession stand right now? Because there's a lot of... No. Okay.
What?
Well, we're watching a video, and there's anyway. I just hear rumbling in the audience. Okay, so this is called the commutative property. So this dot this is equal to. It doesn't matter which order you go to. Okay? You know about that, right? Number 2 says that 0 dot v, where 0 is a vector, not the number 0, but that's the 0 vector. Okay. Which is a vector with 0i plus 0j. Guess what that's equal to?
0.
0, right? Because if I multiply 0 times a number and 0 times another number and add them together, I get 0. Okay? 3 is, what's 3? U dot, kind of like the distributive property. U dot v plus w is equal to u dot v plus u dot w, right? Which means I can add these vectors together and then take the dot product, or I could take the dot product of u and v and the dot product of u and w, and then add them together. It doesn't matter which order I do that. Okay? 4. 4 says that v dot v is equal to the magnitude of v squared, which is just equal to, if the components of that are like v1 and v2, that's just equal to v1 squared plus v2 squared without the square root sign, because the magnitude of v would be v1 squared plus v2 squared square root, right? So if I take v dot v, all you do is you end up taking the square root thing away. You understand? Kind of. We'll do one like this.
So is that an easier way to find magnitude then?
Well, no, because that's not really the magnitude. It's just v dot v, which is just a squared plus b squared without a square root.
But then
Yes,
you
Leah.
can just take the square root.
Yeah.
What
Yeah.
is W? Because
Oh, sorry. What is W? W is just another vector. So W is some other vector. Okay. Okay. 5. Last property. C, where C is a constant, times u dot v. U dot v is equal to cu. Yay! Go cu times v, or which is equal to u time dot cv. And, okay, that's a dot. That's a dot. So c is a constant. Constant. Okay, and u and v are vectors. So what this says is that I can take the dot product. If I want to multiply a constant times the dot product, I could take that dot product and then multiply by the constant. Or I can multiply the constant times one of the vectors and then take its dot product. And it doesn't matter which one I do. Okay? Either the first one or the second one, and then you take it up. So some examples. So I'm going to add to these 3 vectors another vector, which I'm going to call w. And that vector is going to have components 0, 3. Okay, so going down here, I'm going to do a couple examples. So say you want to find v dot v. V dot v. And I'm looking up here. What's v dot v? It's just -1 quantity squared plus 2 quantity squared, okay? Which is equal to, so you don't have to square root it, right? It's just the first part squared plus the second part squared, which is equal to 1 plus 4, which is equal to 5. Yes? What is u dot v times w? U dot v times w. What would that be? Well, u dot v we found up here, right? U dot v is -10. So it's just -10 times, so this doesn't give you a scalar, this is going to give you a vector, right? Because it's -10 times the vector with those components. You understand what I did? Actually, I should put the negative, doesn't matter which side I multiply. So -10 times 0 is what? 0. And -10 times 3 is -30. So that's the vector u dot v times w. Okay, so that returns a vector, not a scalar. Okay, so there's some examples. We're not done yet. Sorry. Okay, so now one thing that dot products are useful for finding the angle between 2 vectors. And this just comes out of the law of cosines, if you're interested in where it comes from. 2 vectors. So the formula is cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. Okay? So say I have two vectors. We're going to change what they look like. U equals negative 2, 3. And V equals 1, negative 5. And I say find the angle between the vectors. Find the angle between U and V. All right. So sometimes it's helpful to draw a sketch. So negative 2, back 2, and up 3. All right. So if this is my starting point, let's say there's a starting point. I'm going to go back 2, up 3. So let's say that this vector looks like that. Okay. And then I have another vector that's over 1 and down 5, which probably looks more like this. Okay. And so what I'm finding when I'm finding this, the angle between two vectors, you're always looking for the angle that's less than 180, between 0 and 180. Okay? And so to find that angle, I'm going to go u dot v. Okay, so here's theta over here. So u dot v is negative 2 times 1 plus what?
Negative 15.
Negative 15. Oh, you did that in your head? Oh my goodness.
Oh, I know.
No
I'm
wonder
a
you're in the
math
advanced
whiz.
class. Okay. So equals cosine theta. Whoops, I forgot the bottom. What's the magnitude of u? What's the magnitude of u? Square root of 13. What's the magnitude of v? Square root of 26. Okay. So how did I get those? Any questions on how I got those? Magnitude of u is 2 squared plus 3 squared, square root of that. Magnitude of v, okay? And then if you do this on your calculator, you get the cosine of theta is equal to negative 0.92. Might keep going, 9246 or so. And then so I would take the inverse cosine of negative 0.9246. And that gives you an obtuse angle, right? It doesn't give you a negative angle. It gives you an obtuse angle, right? Because cosine is negative. Inverse cosine is negative in the second quadrant. And you get out 157.6 degrees. Questions about that? What was I saying about negative? Because this is a negative, that's got to be an obtuse angle, right? Because inverse cosine is negative in the second quadrant. Okay? Almost done. Next thing. New page. Next thing. So, if I multiplied through, I would get u dot v equals the magnitude of u. Magnitude of u, so that same formula, if I cross multiplied, I would get this, right? Okay? And if u dot v equals 0, that must mean that either one of these is the 0 vector, okay? Or the cosine of theta equals 0. If the cosine of theta equals 0, if cosine of theta equals 0, when is cosine theta equal to 0? At what radius? 90 degrees, okay? So if u dot v equals 0, the vectors are orthogonal. That means perpendicular, but they use big words. Orthogonal,
You
okay?
just write perpendicular?
Yeah, it means perpendicular. To tell you the truth, I'm not sure what the difference between perpendicular and orthogonal are. But orthogonal means at right angles to each other. Okay? And then also, furthermore, we're almost done. Furthermore, if this expression, u dot v over the magnitude of u times the magnitude of v, if that's equal to 1 or negative 1, what's going to be true about those vectors?
Parallel.
they're parallel, right? Because the cosine is 0, right? That would mean that the angle in between them is 0 or 180, right? Which means that they would be parallel, okay?
Are they parallel or are they just on top of each other?
Or they could, well, they could be on top of each other, yeah. They could be, but, yeah, they could. If one is just the other vector times the other vector, then they'd be on top of each other. They could be the same vector, but they're going in the same direction or opposite direction. Yes, Ambry?
What did that say?
Which?
Have u dot v over that, and then have an equal sign, and then.
Oh, 1 or -1. Oh.
I thought it said the L or. No, I thought it was like the absolute value minus bars. Like
Sorry.
or minus.
Yeah. That's, okay.
No, that's what I thought it was.
One more quick. So 2 quick examples. So you'll have some problems that will say, are you negative 4i plus 2j and v equals I plus 2j orthogonal.
No, wait, what is ARE?
R, it's a question. Okay?
Oh! Actual question, okay.
So, orthog. So you find the dot product, okay, which in this case is -4 times 1 plus 2 times 2, which gives you out 0, which means these are, what's true? If the dot product is 0, then they're orthog, okay? Orthog. Orthog.
That sounds like the name of a barbarian.
Yeah.
Like some sort of really cool sword and sandal type hero. Just Orthog. Like Orthog the Conqueror?
Yeah.
That would be a cool.
We're
I would
being
want
recorded
that.
right now. Okay. So let's move on. Last thing. Okay. Given, so you'll see some problems that look like this. This is just a. This is just kind of an application, maybe not an application, but just kind of a problem where they like to confuse you. U equals 3i plus 2j, and b equals 2i minus kj, and they'll say find the value of k that makes the vectors orthogonal. Orthog, there he is again. Orthog. He kind of, okay? Could you do that?
Probably.
3 times 2 plus 2 times what? Negative k equals, right? 2 times negative k, right? Equals 0. And then you just solve that. So you get 6 equals 2k, k equals 3. The end. That's the end of my...
Hold on.
Wouldn't it be -3?
No, because it's -2. Okay, so that's it. You can do your homework. I will... I'm going. Just chill.
Definitely not. I'm going to Jordan's doctor's like after school. It's like,